have 9 a.m. next semester. It's kind of like it's all top, so I have to get up. Have you guys voted yet? I can't vote. May. I just do a year or what? I graduated a year early. But yeah, I turned.
Okay, let's get started. Here was the one that caused the most difficulty, and I was expecting that, so it's a good one to talk about. So we've got, basically it's a composite function, but it's like 3 deep, okay? So it's a function within a function within a function. So we've got 7x as the input into cosine x, and then cosine x is the input into sine x, and then sine x is the input into what? To the ninth, that's right, exactly. So now we're getting into the types of problems today. We're going to start seeing the types of problems that we're going to have in the mastery exam Thursday. So this is definitely in that ballpark. So we always ask the question first, what's the structure? What's the big picture of it? Is it a sum? Is it e to the something? Is it a power rule? Is it chain rule? Is it a composite function? Is it a product of two functions, etc.? So what is the overall structure of this? What's the big picture of it? So we can rewrite it this way. So that original function is the same as sine of cosine of 7x. And that all to the ninth. So when they have the 9 after the sign like that, it just means you're going to evaluate the sign and then take it to the ninth. So what is the overall big picture of this original function? Is it sine? Is sine the big picture? Will? Okay, chain rule. Right, so then what is our exterior function? So with chain rule, what's that? Raised to the ninth. So because the exterior function is something to the ninth, that's what we'll apply when we want to find the rate of change function. So what is the rate of change of something to the ninth? 9 times the something. Remember with the chain rule, the interior function stays as it is. Remember that? Okay, to the 8th. But then by the, so go ahead. Yep, by the chain rule, now we got to multiply by the derivative of the interior function. What about that? What's the structure of the interior function? It's also a composite function, so we have to do the chain rule. So what's the structure of that? What's the big picture of that? Sine. So we're going to do the cosine of, keep the inside as it is. Okay, so we're doing the rate of change of this, which is its own chain rule, so it's going to be cosine times the, or cosine of the interior function as it is, times what? Times the rate of change of the interior function, which would be minus sine of 7x times the interior rate of change of 7x, which is 7. So what we see is that 7, so here's a little chain rule. This is the rate of change of that. And this is the rate of change of that. So the whole thing is, so you can think of it as the rate of change of the exterior, 9 times the something to the 8th, times the rate of change of the interior function. That's what I've put in red. This whole thing is the rate of change of the interior function. So to do that, we need cosine. So that's its own composition or chain rule. So the minus sign is the rate of change of the interior, and the 7 is the rate of change of the interior there. Okay, does it make sense? Anybody have a question on that? Yes, ma'am.
Would you do the 7 at the end? Would you multiply that by the 9 again?
Yeah, so we could change things around and kind of simplify it. Yeah, so we could, if we want to do 9 times 7 would be 63. But for our purposes, like for this week for the mastery, just writing down the first step will be enough. You don't have to do any algebra, because our goal is not can you do algebra. It's do you know how to use the rules in combination, okay? For finding these closed forms. So that's acceptable for mastery. Okay. Any other questions on this one? Okay, so we have yet to do rules for functions that are products of other functions and functions that are quotients of other functions. So we'll do that today, and then we pretty much have almost everything to tackle the types of problems you'll see on the mastery this Thursday. Okay, so I'm going to need to kind of go through the slides quickly, so you might not have, if you'd like to copy down everything on the slides, you might have to go back to the video, because I may go a little quickly. There are some things I will point out that you definitely want to copy down now, but just be aware that some of these things I'll have to go through fast. Okay, so suppose that f and g are sine and e to the x. So here's a function that's made up of the quotient of those two. Here's a function k that's made up of the product of those two. So the question is the rate of change of the quotient equal to the quotient of the rates of change? And is the rate of change of the product equal to the product of the rates of change? So we saw a similar rule where this was true before. Do you remember which rule that was? What's that? Sum rule. The sum rule, right? And we said, what would we hope for, right? What would be great is if the rate of change of a sum of functions was just the sum of the rates of change. We could just do each one individually. Okay? So wouldn't it be great if this was also the case? Okay? So, but we're not so lucky in this case. It doesn't work. You can't. Calculus students throughout the ages have tried, but they've gotten it wrong every time if they tried to do this, okay? Don't do this. So we're about to find out what the rules are. But if you have a quotient, you can't just take the rates of the top and the bottom and make a new quotient to get the rate of change. Same with the product. You can't just take the rate of change of each and multiply them to get the rate of change. Okay, so let's do product first. So just for a second here, where am I? Ignore that. Okay, so here, this is signifying two functions that are in a product. Okay. So what we want to do is, if we want to figure out what the closed form is for the rate of change of two functions that are multiplied together, what can we do? So this is what we're going to trying to be training you throughout the last week. What would our first step be? So, okay. She said open form. Is that how we start? Yeah. So we always start with open form. So can you write? So what would R of f times g of x be in open form? So write that down. So what would r of f times g open form be? Jerry, can you tell me? What's that? Yeah, can you tell me what the open form would be for f times g of x? How about Jimin? Can you tell me open form?
F of x plus h times g of x plus h.
Okay, all right, so you're one step ahead. That's good. So can we just do f times g of? That's good? No, you're good. But just for everybody else, what would it be? F times g of x plus h,
Minus f times g of x
right?
over h.
Over h. Okay, so now let's look at the definition of f times g of x. Well, that's just x times g of x. So now given that definition, can you write the next step? So given that the definition of f times g is fx times g of x, can you make heads or tails of this? Joe?
So can we do f times x plus h, I mean f of x plus h times g of x plus h
F of x plus h times?
minus f of x times g of x over h.
Yeah, so if f times g of x is just f of x times g of x, then f times g of x plus h means our new input is x plus h. So it's just the product of the functions with the new input x plus h. Okay, so this is something we've seen over and over and over again, so we got to make sure we really are comfortable being able to do that kind of thing. Given some form of a function, whether it's product or sum or constant multiple or quotient, that we can always get that first step and write the open form. Okay, so that's what we had. So the next step is something that you wouldn't necessarily come up with yourself. Okay, so I'm going to give the next step. And then the next step is I'm going to insert in here this minus f of x g of x plus h plus f of x g of x plus h. Why can I do that? So what? Yeah. So he says, and if they cancel out each other, then what is that like doing? What is it that I just did? What did I just do by inserting all that expression in red?
Zero.
Yeah, I just added 0 in there, right? So I just did this plus 0 minus this. So it does keep the value the same. Yeah, but adding 0, I'm just keeping I keep the ratio the same, or the expression the same value, but now I'm introducing some new expressions that are going to help me to get where we need to go. So this, in red there, I might as well do it in red. So this whole thing in red just equals 0. So it's fair. So I'll give you a hint for the next step. So the reason that we did that was now I want to group together the first two terms and the second two terms. So take a minute to see if you can see what we can do now. So my hint to you is group together the first two, group together the second two. What can you do next? See if you can do it. What does that grouping push you to do, or kind of coax you to do with each of those? And you can talk amongst yourselves if you want. Ashlyn, did you notice what you can do?
You could take out G of X plus H and then X.
Okay, in the first two, she's saying you could factor out G of X plus H. And the second two, you could factor out F of X. And when you do that, you should see something start to form. Do you see what happens as a result of that? Anybody, what do you notice then? Something starts to take shape. Danny. Daniel. Okay, be more specific. Yeah, so when we pull that G of X plus H out, the rest looks like something familiar. Similarly, in the second term, also looks like something familiar, right? So, see if you can do the next step. See if you can do the next step. So we have a common denominator. We can go backwards, right? We can go backwards and pull fractions apart, each one with the same common denominator. So Charles, do you see what's next then? So what will come next?
We have G of X plus H over H times the rate of F of X.
Okay. So the first one will be G of X plus H times that thing that I put a square around, which is
The
rate of change
rate
of
of change of function F
with respect to X. And then what will the second term turn out to be? Crystal.
Rate of change of G with respect to X.
Times. Yeah, so we'll have G of X plus H times this ratio we know is very familiar, and then F of X times that one. So now we're ready to let H get very, very, very small. So when H gets very, very small, what happens to that? What does that become? Just G of X. H gets, very, very small, so this is G of X. As H becomes small, that is?
0.
No.
F of X minus F of X.
No. What is this when H gets very, very small? Utah. The rate of change of F of X. It's the exact rate of change function. When H gets very, very, very small, we get the exact rate of change function. Same with this one. So we got G times the rate of change of F plus F times the rate of change of G, and all I'm going to do in the last step is just reverse them. So all I'm going to do in the last step is just switch the order. So if we have here's the, we'll do it on the next screen. So what do we find? If your function is product of two functions f times g, then the rate of change is not the rate of change of f times the rate of change of g, but it's this, which involves those rates, but it's a little more lengthy than that. Okay, so we've got f times the rate of change of g with respect to x plus g times the rate of change of f with respect to x. Okay, so this is definitely something you want to get down. So you don't have to write both. So our notations are interchangeable. Prime, the R notation, the D notation. So you can just put one just as long as you know how to write the others. But this is the idea verbally. The rate of change of a product is the first times the rate of change of the second plus the second times the rate of change of the first. It's easy to memorize because of the symmetry of it, right? You're going to take one of them times the rate of change of the other, and then you're going to add the reverse of that. And just get the second times the rate of change of the first. So product, this is called the product rule. It's pretty easy to remember because it's perfect symmetry, right? And you don't even have to, it doesn't matter which one you get first. Because you're adding, right? Adding, you can switch the order. Okay, so let's apply it. So when we apply it, so here we have the overall structure as a product. So because the overall structure of this is a product, our plan of attack is to use the product rule. So first we identify our two functions. So since the function is called f, we need other names besides f and g, so we'll say g and h. And so so find the rate of change of f. Who can tell me in terms of g and h, what will the rate of change of f be in terms of g and h? Sam?
Would it be 2x to the fourth power minus?
No, just in terms of g and h. So just forget about that. Just in terms of g and h.
G of x times the derivative of h of x plus h of x times the derivative of g of x.
That's the product rule, right? So, and this is just a side note. So we can use the r, f prime, and d notations interchangeably. They all mean rate of change function. In certain contexts, it helps us to use one or the other. So sometimes one is more advantageous than another. Okay, but remember they all mean the same thing, the rate of change of the function f. Okay, so if we got a product, our plan is the product rule, like Sam said. The first times the derivative of the second plus the second times the derivative of the first. So let's get the building blocks. So we got the overall plan. As part of that plan, we'll need the derivative of the first function, or the rate of change, 8x cubed. What's the rate of change of the second function? 6x, right? So these are some building blocks, but we don't lose track of the big picture, or the overall structure of it. So we just plug everything in. First times the rate of change of the second, plus the second times the rate of change of the first. Anybody have a question? Does it make sense? Again, just to reiterate, the rate of change of f is not the rate of change of g times the rate of change of h. But what happens is sometimes you'll get in a situation where we're thinking about other things. We've got an application problem, or we've got a more complicated rate of change function to find, and you'll forget, and you'll tend to do that. So you've got to really be, whenever you have a product, you always will use the product rule to find its rate of change. Sam?
For a mastery exam, would that be our final answer?
Yeah, you can make that the final answer, right?
Yeah.
So we know we could do algebra on this, and we could do a couple steps and make it more concise. That's not our interest for the mastery test.
Does the order matter? Like, can the 6x be in front of the 2x?
Okay, so can these be switched? Is it okay? Is it still the same? Yeah? Can these be switched? Yeah. Can these be switched? Yeah, that's the thing about product rule. Yeah, all the orders are okay. Quotient rule is a different beast, but with product rule, yeah. Multiplying, we can change the order. Addition, we can change the order. Okay, so let's do quotient. So we can do quotient using the product rule. So what we need is, can we rewrite f of x divided by g of x? Can we rewrite that as a product? And if so, how can we write that as a product of two functions? Will? He wants f of x times g of x to the minus 1. What do you think? Would that work? That's exactly what it is. So now we can apply, since that's a product of two functions, we can apply product rule. Okay, that will involve, we'll have the first times the rate of change of the second. When we get to that part of the product rule, the rate of change of the second, what will we do? Recognize that? So we got g of x, some function, then raised to the negative 1. How will we attack the rate of change of that second function within the product rule? Somebody new?
Use the chain rule.
Is it the chain rule? Is that a composition of functions? Yeah, it's one function is the input into another function, x to the minus 1. So some function g of x, which would be our denominator, raised to the negative 1 is a composition. So we need the chain rule. So we're going to have the chain rule within the product rule. So what will the chain rule be? What will that be? Just the rate of change of the first function. How will we do it? Savannah, can you do the rate of change of that? Negative 1 to the negative 2 What do you think? Yeah, that's it. That's the chain rule. Leaving the interior function as it is, apply the power rule, negative 1 times that to the minus 2, and then times the rate of change of the interior function. So there it is. So here's writing out the product rule, and then here's that step that she just did for us. The rate of change of that first function. Rate of change of the second. Rate of change of the second. Is right there. So notice it's better to use the D notation, because if you use the prime notation, it would get a little confusing, because here we got the raised to the negative 1, and then to put a prime is kind of hard to understand. So it's better in this case to use the D notation. That whole thing is those are equal. This is applying the chain rule to this function right there. So I'm going to, the rest is just algebra and moving symbols around of fractions. So let's just get to the punchline. And here's the punchline. Okay, it's the denominator times the rate of change of the numerator minus the numerator times the rate of change of the denominator over the denominator squared, which came from the product rule of our equivalent function here. Again, this is just working with fractions and algebra to get there. Yes, sir?
So the top part would be the same as when you multiply it. The numerator would be the same as when you multiply to rate of change function?
No, because it's minus, so now the order matters.
Oh, I
See, because it's minus, you can't just switch them. It's kind of like it, but because it's minus, you've got to get this order right now.
Oh, I see.
Okay, again, R notation or prime notation. They both say the same thing. The R notation, our rate function notation, or the prime notation, both saying the same thing. And then here's the D, and then here's even short. So get these down. These are even shorter hand. Just get rid of the x's. We know G and F are the functions. We know they're both functions of x. So an even shorter version is just to write this. F over G prime equals GF prime minus FG prime over G squared. Again, all three exactly the same. They're all different ways of expressing the exact same rule. Okay, so this takes a little more effort to memorize. You do need to memorize it. So here's kind of a trick. It's like a chant, okay? You can do just chant. So if we call the numerator the high function and the denominator the low function, so we started off with that we're doing f over g, right? So if we call that the high function, it's up high, right? And this is the low function. And then rate of change, we know, is this d for derivative or rate of change. So then here's this kind of helps a little bit. So low, meaning the low function, d high, rate of change of the numerator, minus high d low over low squared. And it's off to work we go, right? Does that make sense? So then, really, all you need to remember is the first, if you could just memorize this part, then the rest falls into place. If you just remember low d high minus, then the rest kind of falls out because it's going to be the other minus high d low over low squared. So with product rule, all you have to do is remember the symmetry of it. You got the two functions, one times the derivative of the other, plus, now switch it, right? This, you got to make sure we get, you can't just switch these because it's minus. You can't, if you switch those, you get a different answer. You've got to get the right one first. Low d high has to come first. Minus high d low. Okay, so practice. So our h function is sine over e to the x. What's the overall structure? What's the overall structure of sine over e to the x? Is it product? Is it a sum? Is it a quotient? Is it something to a power? The overall structure is a quotient. So our overall plan of attack will be quotient rule. Remember quotient rule is low d high minus high d low over low squared. So you're applying it to that function. Okay, who wants to tell me what you got? So you don't have to do any simplification, just... So how about, Lauren, did you get it? Okay. E to the x. Okay. Mm-hmm. Okay, what's the rate of change of e to the x? Remember what that is? This is in power rule, because power rule is x to some number. So this isn't power rule because x isn't the base. So power rule is when you have x to a number, like x to the 8th. But e to the x is totally different. Do you remember what the rate of change of that is? It's and natural log of e is just 1. So this one is, remember this is a very special function where its rate of change is the same as the accumulation. So yeah, so you had it just except for that one part. Low d high minus high d low over low squared. So this, the rate of change of e to the x is just e to the x. Questions on that? Everyone got it? Okay, product rule, same ones. So if k is sine times e, Nathan, you got a question?
Yeah, you just factor out e to x.
Yep, you can. Yeah, so he's noticing that we could do some more and make this simpler, right? We could factor out e to the x, and then it can go with one of these down here. If there's 2 in the denominator, there'd be 1 in the numerator. So we'd have cosine x minus sine x over 1 e to the x. Yeah. All right. For mastery exam, just stop here. Stop there for mastery. Okay. So try product rule, same functions. So sine x times e to the x. So k is sine x e to the x. This should be easy. Just apply the product rule because it's a product. Nicole, did you get it? Okay. Is it Myra? Did you get it? What is the product rule? Remember what the product rule is? Saskia?
You want to know the product rule?
Just in terms of f and g. Okay?
In terms of f of x times the d over dx of g of x.
Which is what? What does that mean?
Rate of change.
Rate of change, okay.
Plus g times the rate of change of f.
Right. Product rule is first times the rate of change of the second plus second times the rate of change of the first. And so now we're ready to apply it. Somebody new. Ben, did you get it?
Sine of x times e to the x plus cosine x times e to the x.
Nailed it. Anybody got a question? Again, we could factor out the e to the x here if we wanted. Questions? Going, gone. So there's the factoring. For mastery, optional. Okay, how about this? So now we're getting into some more like mastery type problems. We have to use the rules in combination. And when that happens, it often gets confusing. Here's how you can kind of make the first, correct step is what I've been saying. Look at the overall structure. What is the big picture of that function? And then that will tell us what rule to use, and that will be the plan of attack for the whole problem. Then within that, we'll have other things to do. Okay, so is it a sum? Is it power rule? Is it a product? Is it a quotient? Quotient. So plan of attack is to use the quotient rule. So we'll break up our numerator and denominator, and we know within the quotient rule, we're going to do the rate of change of each of these within the quotient rule. So when we get to the rate of change of f, what will we do?
Chain rule.
Okay, chain rule or product rule? Which is it? Is this one function as the input into another, or is it 2 functions multiplied? Yeah. It's sine, cosine is the input into sine, so it's a composition. So it's chain rule, right? So within the quotient rule, when we get to the rate of change of f, we'll be applying the chain rule. And within the quotient rule, when we get to the rate of change of g, what about that? Power rule? Chain rule? Roman.
I'm feeling the chain rule.
He's feeling the chain rule. Why not the power rule?
The power rule just seems more complex, whereas the chain rule, you can just break those up into different functions.
Okay, so we can't choose to use either one. We've got to use one or the other.
That's why I'm going with chain rule.
Yeah. Well, it just kind of sounded a little bit like you were saying that you could use either one, but you choose chain.
Oh.
Yeah, you can't use power rule because it's not x to the something. If it were x to the something, then we could use power rule. But because it's e to a function of x, that's got to be exponential rule. Okay, so we use the quotient rule. And so before we put this whole thing together, let's do these sub pieces. So let's as sub goals, let's find the rate of change of f and the rate of change of g. So there's the rate of change of f. That's our chain rule. Can anyone give a stab at the rate of change of g before I put it up there? Anyone want to try rate of change of g? Calvin.
E to negative sine x 3x. Sorry. E to the negative sine x 3 or sine 3x.
Right?
Times cosine or negative cosine 3x times 3x or 3.
Yeah, you got it. So, and then this is changed around a little bit. So here's what we do first. Okay, so first it's e to the something. The rate of change is that e to the something, and then times by the chain rule the rate of change of the plugged-in function, the interior function. The rate of change of the interior function would be negative cosine of 3x times 3, again by the chain rule. So what are these? These are just parts of the overall plan we had to use the quotient rule because our original function was a quotient. So all we do now is we just plug everything into its place on the quotient rule. We've got everything. We've got all four. We've got the high, and we've got d high, and we've got low, and we've got d low. So just plug them all in. So it's long and it's ugly, but if you see it in its just parts, it's not bad. It's just all we had to do is really it just came to doing these two chain rule and knowing that we had to use the quotient rule. The quotient rule being low d high minus high d low over low squared. This is what the mastery exam is like, using the rules in combination.
Please just leave the answer.
Yep, please. Yes. Other questions on this screen? Okay, here's the overview again. What's the main plan of attack? Realizing that it's quotient rule. Getting the sub-pieces with the quotient rule. And then just following the rule. Can I go on to the next screen? Okay, so here's what we got so far. We know how to do rate of change of a constant function, constant multiple, sum of functions. We didn't do piecewise, okay? Square root function, exponential function, composition or chain rule, sine or cosine. Now we've got product and quotient. So a mastery test is about what? It's about practicing these. It's about remembering the rules and using the rules in combination. This is the mastery test. Yes, ma'am?
Will we still get 2 attempts on the mastery exam even though we're behind?
Yeah, you get the first attempt is Thursday, and then you get a second attempt in a week from Thursday. But then you can't get the 100%. So if you pass it on the first attempt, you get 100% for the exam. If you don't pass it and you pass on the second exam, you're going for a lower score.
Okay. And then passing is
85%. So you need to get 85% on the mastery, and I'm 99% sure of that. Okay, so I'll give you all the details Wednesday, but something like around 85%. If you get at least 85%, you get 100 on the exam, and that's worth half of a normal exam. The first question, Ashley. It's enough for now. So Wednesday, if there's not much more. If there is more, and we'll do it Wednesday, and I'll let you know. Jimin. Okay, so let's keep going. All right, so here we'll kind of go fast with the screen. This is just showing that because tangent is defined as sine over cosine, we could find the rate of change of tangent. How? How can we easily find it now?
Using the sine and cosine rule.
Okay, but what's the structure though? Quotient rule. So we could use the quotient rule to find the rate of change of tangent x. And so the plan is quotient rule. So the rest is just algebra and trig identities One identity being cosine squared plus sine squared is 1, and 1 over cosine squared is secant squared. So here's a new rule to add to sine and cosine. The rate of change of tangent is secant squared. Rate of change of tangent is secant squared, just like the rate of change of sine is cosine. Okay, practice. So, we just want to practice talking through in structure, not writing down all the algebra. So we want practice kind of with the overall attack. So we're not gonna write down every symbol because it's going to be long. So let's just practice. First, what's the first question we ask? Overall structure, big picture, which is? Most are saying quotient, that's correct. So plan is, so we've got the numerator and the denominator. Overall plan, quotient rule. We've got a quotient. So now we're going to have low, d high. When we do d high, what will we do? So what is the numerator, or the high function? What's its overall structure? Product. So what's this going to be? We're going to have the product rule within the quotient rule. So when we get to this f prime, that will be the product rule. So let's just see how that plays out. So as part of the quotient rule, we'll need the product rule. That's what I said. So product rule. Don't write everything down. And then this is our d high, right? The product rule is the rate of change of the numerator. And then that's the rate of change of the denominator, so we're ready to write anything down. There it is. So it's low d high, or d high was product rule, minus high d low over low squared. So questions about the overall attack of the problem. Do you understand how the product rule and the quotient rule are working together here? Do you see it? Okay, so here's the general advice. Look for the function structure. Is it built from other functions? So what are examples of structure? Sum of functions, product of functions, quotient of functions. The whole thing is to a power, right? Or composition. Those are all examples of overall structure, and will dictate which rule will apply in attacking the problem. Okay, then look for subfunctions. Look out for composites, chain rule. Okay, if you need to, especially when you're getting started on these more complicated ones, sketch out a plan. And then execute. And then assemble the final result, and the final result goes back to what? Structure, right? The final result, when you write the rate of change function, it's about the structure and the rule you use for the overall big picture. Okay, so one thing we can do is we can check, and maybe we'll do this in one either today or Wednesday, we'll see if we have time. But you can graph the open form with graphing calculator, and then graph your closed form result, and what should happen? You should get the same graph. It should be right on top of each other. So that's a good way to check to see if you got it. Okay, so let's just talk through this one, and then we'll be done. So to maybe talk to the person next to you. What will your plan of attack be for this one? And then what will your sub-plan be? So just talk to the person next to you. What will the plan of attack be? And what will the sub-plan be?
That's the big one.
Big picture is product rule. It's this expression times this one. Okay, so now the product rule is first times the rate of change of the second. Now the rate of change of the second, what is it? Quotient rule. Okay, and when we're doing that rate of change, now part of the quotient rule will be the rate of change of the denominator. What will that be? Product rule. So you'll have the product rule within the quotient rule, and that quotient rule within the product rule. You see? So here's the plan. Product rule is the overall structure. Within the product rule, we have quotient rule number 1. So this quotient rule is talking about quotient rule number 1, which will involve the sum rule, and also what? Power rule. And then we'll have, as part of the product rule, we'll have another quotient rule. And that will involve exponential rule and product rule. So this is how you have to have an organization in your mind when you're attacking this. Okay? In the end, when we write down what the rate of change of G is, what will it look like? Which one will it be? Product rule. When we write it out finally in the last step, after doing all this work, we're going to write out the product rule. Within that, we'll have quotient rule, we'll have sum rule, power rule, etc. Okay, so to get ready for, to start getting ready, the homework will be, I'm going to post a list of 100 rate of change functions, practice, or functions that you're going to find the rate of change for using the rules. And then, I'm not sure yet, but I'll have detailed instructions along with that posting, along that document, so just read the instructions carefully. But it's going to mean doing like 25 or 30 every night till Thursday. Okay? Some of them will just take a minute, others will take a little longer.
Are we still gonna have recitation?
Yeah, we'll still have recitation Friday.